I predict between 5 and 50, but it could probably be maybe something like that. Anyway, this particular presentation is going to be fairly informal, and I hope to take questions if you have some along the way. I got some in advance, and I think some of this presentation answers pretty much all the questions I got in advance, but maybe I'll have something out. I'll introduce the team that I worked with back in the 80s. This Dave Hamilton, Bill Wyckoff, we were a lot younger then, and myself, Bob Monsrud, Dennis Ferguson, Albert Stage, and Melinda Moore. They were part of our research work unit in Moscow. And here's another photograph of a few of us later, but it includes Gary Dixon, who's on the right. And this photograph was taken at the Priest River Experimental Forest. We were doing some kind of a conference. And I don't know what Bob and Bill were looking at, but they were looking off to the side. So really, I'm gonna talk about the story of FVS development and my role in that development. We'll talk about some lessons, and then I'll talk about the development of yaImpute, and which is a related story, but it's not the same as FVS. So it'll be kind of simultaneous. The development of FVS is told by me and my role. I was sort of, I got the impression that was part of the request. So it'll be a bit of both. The research work unit I worked on was led by Al Stage, and in those days, forest research was organized into research work units, where the project leader reported to an assistant director for a section of research, and then there was a director of the research. We started in the Intermountain Research Station, and then that station was merged with Rocky Mountain Research Station. Bob Monsrud was a mensurationist, a biometrician. His most famous work was probably his site index paper, and I worked with Bob to link a Douglas fir tussock moth model to the prognosis model. Bill Wyckoff was a programmer, mensurationist, biometrician, and he worked on the diameter, height, growth, and mortality models. Dave Hamilton did most of the analysis and the studies behind the original mortality models, and then they went into prognosis model. Dennis Ferguson worked on regeneration establishment. He built an independent Fortran program that generated tree records, and then Dennis and I linked his code to prognosis. And Melinda, whoops, I'm going too fast. I'm using the wrong button. Melinda worked on shrubs and cover extension and on MSN, and did some other things before she left the group. I started on the whole project in about 1979, soon after I had my master's degree, and I was first charged with linking a mountain pine beetle model to the prognosis model. It was the second of what we called the bugs and crud models, which represented specific agents in stand dynamics. And it was a second one because the first mountain pine beetle model was actually part of the original prognosis code documented in GTR 133, which was published back in 1973. Al understood that mortality was caused by a lot of episodic events, insect outbreaks, root diseases, fire, and that you really needed to account for those factors in projecting forest dynamics. And his interest was why our group participated in what we as a group called Big Bug programs, which started with Douglas fir tussock moth. I just said that the first model we linked was mountain pine beetle, but that was a model that came out of the integrated pest management program that was funded with through universities, including the University of Idaho. I think Carl Huffaker, some of you may have heard of him, was one of the leaders behind that. So I worked on that, and that's how I got started in working with the group. After the mountain pine beetle, we had this Douglas fir tussock moth program, and Bob was the lead in that group, and I was his programmer essentially. And at about the same time, I built the keyword command system that's used in FVS. From the get-go, we collaborated with the National Forest Systems, and people outside the U.S. might not recognize, or might know and might not know, that the Forest Service, the U.S. Department of Agriculture Forest Service, is made up of three groups, and research is not in National Forest Systems. National Forest Systems actually manages the land. There's another group, State and Private Forestry, which is, or International Forestry is one, and there's smaller groups. They started to establish a group in Fort Collins that Ralph Johnson was sort of the first really active person who got down to Fort Collins and worked on actually providing the model to National Forest System users, people that wanted to use the program. And Gary Dixon followed. Here's a photograph of some of the folks that worked in a group down there. This woman is, the two women are Stephanie Reban, who was very helpful, and Aaron Smith-Matea, who is still in the group. Excuse me. I'm going to take 1 second and get a glass of water. So stand by. Right. Back. Some of the other people in this group, Dave Corse is sitting on the ground. Mike Van Dyke is in the background, and all these guys were helpful to the effort and did a lot of the work of actually making the program, the model available. So I think I might share just some of my memories of Al Sage's philosophy, and one of them was that if people needed help and we could help them, we would. And it didn't matter what organization they came from, their timber industry, state and private, state organizations, or environmental groups, or whoever wanted help. We always would try to help them out. Another philosophy in the group was it's not a mistake until it leaves the office. Now, plenty of mistakes did leave the office, but we didn't count them as mistakes if we were finding them in each other's work. And the other thing that was interesting was it was okay to ask your team members to prove their math and code. If it looked odd to you, you could say, "Could show me," and that was always a permissible thing to do. And lastly, our work was always open to everybody. We would send the program to wherever. And I had a note about the size of the program, but when I first started working on it, I believe that fit in 2 boxes of punch cards. And some people might remember the trivia of how many cards there were in a box. And we'll go back to that later to answer that question. It's a little bit bigger program now. We had a lot of collaborators. I'm not even going to try to mention them all, but one of them that influenced the group was Lou Grossenbaugh. It's interesting to note that a lot of the regression models that were used in the prognosis model were fit using software that Lou wrote. And if you go back in time, you might note that SAS Institute first really had its software available in the late 70s, and FVS started, the first publication was in 73. So if you wanted to build a regression, you weren't going to use SAS, you weren't going to use SPSS, you weren't going to use R. And Lou had a very good inversion routine and a reasonably good interface. And Bill Wyckoff used this program for years and years. Christian Salas was one of the people that might be on the call, and he worked with Al at the end of his career, at the end of Al's career. So when was FES born? It was born about in the 1990s, when Gary Dixon, I think the story is that Gary Dixon called me, but I may have called him. I think he may have sent me a change in the program, and it was a new title, and called the Forest Vegetation Simulator. And I said, well, that sounded fine as long as we can make it to represent all the important vegetation. And he kindly informed me that nobody was asking my opinion about this change. It was an edict. So the name of the model was dictated by Washington office vegetation management, timber management staff directors. Otherwise, it would have been the prognosis model. So my role is I had very little to do with actually modeling growth, mortality, and volume equations. That was Bill with Al, Ralph Johnson, Gary Dixon worked on other regional variants. And over the years, several other growth and yield models were folded into the FES framework, sometimes without regards to the desires of the other model authors. And so our group was mostly working on what we call the Inland Empire variant and some of the areas around North Idaho, Eastern Washington, and Montana. And we really didn't build the other regional variants. They were done by other people. So insects, as I mentioned, I worked with Bob Monsrud on the Douglas fir tussock moth. But then I headed up our group's participation in the CANUSA. There was a Canadian USA spruce budworms program that was trying to include the effect of spruce budworm on forest dynamics. And I wrote the vegetation dynamics and the impacts of defoliation. I wrote those components. And that model is still available. It's used some, and it's probably, I don't know that the population dynamics component ever was really used very much, the insect population dynamics, but the defoliation and where the user just specified the amount of defoliation and the impacts components were used. Later, a, a woman named Elizabeth Reinhardt, who was at the fire lab in Missoula, Montana, and I started to collaborate on the development of the fire and fuels extension. And that actually started with some conversations with our bosses. But then I remember having a conversation with Elizabeth, and Elizabeth says, "Well, Nick, they're never going to give us any money. So, but if you want to ask, I'll help you write the proposal." So I wrote the first proposal, and we got it. We got it funded and got started. Brought in a lot of collaborators, and we built the fires and fuels extension. And it's probably the most widely used adjunct to FVS. At any rate, I'm pretty proud of it. Later, one of the folks down at the Forest Management Service Center, I mentioned her name, Stephanie Reben, did a lot of the work. The most recent work I did was to try to represent climate change in FVS. And I worked with Jerry Rayfeld, who was a ecological geneticist in our lab. And we worked on climate change impacts on species distributions and incorporated those into the model. One of the things that exercise did was point out that in some situations, we really need to build a client server type interaction, because some of the calculations need to be done by other processes outside the growth and yield framework. So actually, that's what we have. We have a website that's still being maintained by Phil Radke at Virginia Tech, where people can get the input for climate FES. The point being that we don't run climate change models in FES. Those models are run outside, and we just take the results and the futures from those models and plug them in. So philosophically, that sort of changes a little bit the way you think about how to build these systems. You can't just have everything built into the model sometimes. One of the groups that we worked with a lot was a company called ESSA Technologies in Vancouver, British Columbia, which was an outgrowth of Carl Huffaker's graduate students years ago. So the key names of people that worked with them, we worked with, are Peter McNamee, who left that company several years ago, Werner Kurtz, Sarah Buchema, and Don Robinson. We worked with them on the Budware model. I worked with them on just about all of the model extensions, including the fires and fuels extension. I'm covering some things, or some of the questions. So it was pointed out that my background is not in computer science. My undergraduate degree is in botany, and then I went to forestry school. And the question was sort of, how did I end up doing a lot of computer stuff? And it was because I spent the time learning it. And I basically allocated about 20% of my time learning new tools. And then I really learned them when I applied them. That's how I learned R. It's how I learned C++. It's really how I learned Fortran. It's how I learned C. And SQL was basically, I just dove in and hacked away at it until I learned it. The other thing is that it was really, I was interested in that. I was interested in bringing those technologies to forestry, and I turned out to be kind of good at it. So that was my skill area, as opposed to, say, some of our other colleagues whose skill areas were in really cool experimental designs or really cool ways to use modern statistical techniques, ending in more defensible model builds and equations, which is important to the whole field, but it wasn't my forte. One of the things I built was an interface between R and FES, and partly it was to support what the interface that we now have, which runs as a Shiny application, what I call FES Online. There's actually at Virginia Tech, there's a facility set up so that people can just set up a project and run FES through their web browser on Phil's computer. And the RFES code is part of that. But the main goal of RFES was to, was to provide for faster model building. What I was seeing was that it was taking a huge amount of effort to build a new regional variant of FES, to go from doing the model fits to having the code built into FES so that you could make predictions. And by the time you got to that step, that needed to be an iterative process, because when you build a prediction model, say height growth, this is an example I keep thinking about. You have a height growth model, and it works great in the sense that the residuals look great. You've really captured the process. But when you fold that into a simulation model, you're using it iteratively over time, and frequently the model will break down because, a good example is you build a height growth model based on young tree data, and then keep using it iteratively over time, so the trees get big. The model might not contain the appropriate components to shut down height growth as the trees reach their limits, and that might be due to the fact that maybe there was no data in the analysis data set to support those components. Anyway, you put those models into a simulator and you find the problems. And so I was looking for a way to say, well, how can we speed up this process so that model developers can test their model frameworks with a lot less effort than having to reprogram all the equations into the Fortran code. And so you could, for example, just use with RFES, you could just replace the increments that a variant of FES computes with increments that you compute with a model object from R. And that's one of the purposes. But the only group that's really used that capability is Aaron Westkettle's group and the Acadian model, which is all written in R and interacts with FES through the RFES interface. There was a question about FES running on other systems. And, you know, we always had to run FES on various systems. And I can tell you, I can just report that FES does run on Linux. I run it on Mac OS, runs under Windows. It's been set up by some people under Docker Hub. The FES has been linked to C# using the same API code that was built for RFES. And so it's flexible in that sense. There was a question asked about debugging and some of my experience. For the whole time that I was involved with this program, we needed the program to run on multiple computer systems. Originally, it would be IBM mainframes, which any PC right now is faster than the mainframes we had those days, and the UNIVAC system that the Forest Service had in Fort Collins. And what we found was that having to do this porting actually was an asset. It seemed like a pain, but it really helped us because different compilers found different errors. And I've come to believe that testing on different systems is a very good routine practice for anybody's software development if they can possibly pull it together. Use, even on the same computer, use more than one compiler. Now, I don't use more than one compiler, but I know on Windows, I know of groups that use different compilers. So collaborators, some people are used the base model distributions for Windows right now is built with the GNU Fortran and C compilers, but I know that it's also being built using Microsoft. I'm not sure which Fortran compiler they have, so you end up seeing the results from other code, and that exposes things that are wrong with the code, not wrong with the computer, not wrong with the compiler. The other thing I'd say is that learn to use your debugging. There were failures that were happening in the Forest Service that I found using the GNU Fortran and debuggers that were somehow escaping them. And these as I said, these errors are due to incorrect code. So just because it runs on one doesn't mean it. Now, I did find one time in my career, I found we had a run failure that was due to a compiler error. And that was in the early 80s on IBM Fortran, G-level Fortran back in those days, which was a free compiler. So universities had it. And yeah, so it's possible, but it's not very likely these days. I've been going kind of fast. Do we want to take any other questions about FVS? Because I was going to move on to yaImpute and so on. Or we could just take questions at the end on anything.
Whatever you prefer, Nick. If you want to take questions now, the chat is open for participants.
Well, we can break in. Anybody can break in anytime. I'm going to go into this because you brought up that I was an author of yaImpute, and I'll tell you the story of that development. It started as most similar neighbors, and it was Al Stage's idea. In our group, it was his idea to impute detailed inventory data to stands where only remote measurements were available. And you find by finding nearest neighbors. And Melinda Moore in our group was tasked with building the most number, the MSN program, which was based on canonical correlation as a way to project the multivariate data into some kind of space that where Euclidean calculations were appropriate. So that's how that got started. And I came along and I worked on some of the program. At the same time, Janet Oman at Oregon State had approached the same problem, but she used canonical correspondence analysis instead of canonical regression analysis. So her basic idea was the same pretty much. And she and Melinda collaborated on some work at various times. I was not particularly involved in their collaboration, but I know they collaborated, visited each other and worked on some things. So I came along, or I decided to work on yaImpute when I got a call from Andrew Finley, and some people on the call might know who he is. He's at Michigan State. And he called me one day and says, and he put in quotes, "We build an R package that contains several methods." And then he said, so then we can use the approximate nearest neighbor code that was available in an open source way, rather than the brute force search algorithms that we were using at the time to find similar neighbors. And so I was looking at that and I thought, well, there's a lot of other things that I don't want to program. I don't want to program finding the eigenvalues. I don't want to program, any of these regression methods. They're all already built. I just need to call them and put it together in a package. So we dove in and did that and started working on that. And then I had read about random forest. We were using random forest for some other purposes, and it became a major tool in the climate work that I did with Jerry Rayfeld. And I read Leo Brayman's paper, and he said that the proximity scores and the proximity matrix could be thought of as a distance measure. And so I thought, well, that's cool. It also, random forest can deal with a mixture of continuous and categorical variables. And we have a lot of situations where we have continuous and categorical variables, and they don't lend themselves all that nicely to linear regression frameworks. You can do it, but it was not so straightforward. So I decided to work on incorporating this random forest technique for finding nearest neighbors based on random forest decision tree technology. And that, let's see if the next slide. Well, okay, so that that required me to solve a problem, which was that the proximity matrix is n by n, and can't be stored on a lot of our problems. A lot of our problems are just, they're just too big. So I wrote some code that efficiently finds the 5, 10, or 3, or however many neighbors you want. It's also kind of cool that I know that at least one case where that's being used in Alzheimer's research right now, because it can efficiently find neighbors. So that came around. One of the other people that was involved in yaImpute was John Colson from Forest Inventory, and I met with him a few times, and he suggested some changes, and he was a very good multivariate statistician. And now Jeff Evans maintains the package. He works for the Nature Conservancy, and but I met him when he was working in Moscow. Okay, that's it for my presentation. And I want to get back to this.
Thank you very much, Nick. Well, as I announced the webinar, so we have 15 minutes for questions. Please feel free to write anything you want to ask Nick in the chat, and he will reply. I have questions if you don't.
Okay.
So, well, I'm going to start just to see if people decide to or to ask something. So you mentioned Lew Grossenbach. So I think he was one of the persons that introduced the reloscope sampling in the US. And one thing that I always found very interesting of FVS is that it's very flexible handling sampling design. So it's that's something that came from that interaction with Grossenbach?
I don't know. I just don't know. I think that that Al just understood all this stuff. So I think it was just a matter of course. It was from the very beginning that there was a lot of flexibility in sampling design. It was So I don't know that was an influence of Lou, but I do know that Lou and Al corresponded, because after Al retired, actually after he passed, Al's old office still had all his file cabinets in it, and Kim Isles, whom you may know, came to visit, and he found a bunch of correspondence between Al and Lou, written on what we used to call speed memos, which were just little handwritten memos that the Forest Service used to use. They were kind of cool. Anyways, but I don't think that Al included that sampling design flexibility because of Lou's influence. Lou's influence had to do with this regression package. I mean, I still can't believe that so much of the model building was done using this homegrown package, but written by somebody who really knew what they were doing.
There are some questions here. So there is one question from Patrick Fagetti. He says, "Hi Nick, thanks for the presentation and great to see you. Can you talk about, if any, and how people have mapped and used nearest neighbor distance in forest management?"
Well,
So,
it's used for landscape analysis to impute inventory data to stands where there's no detailed inventory data, and that's often it only revolves around the nearest neighbor, not second, third, fourth, or some weighted average of attributes. And it's to get tree lists to start FVS. I don't have other examples of it. I know that outside of that context, outside of forestry, neighboring is used for a lot of other purposes. And I know this one biomedical example, it was to try to relate information about patients to cognitive decline scores. So, yeah.
people are mentioning the use of yaImpute in the tree map project, and as another application that is it's a big project that is relying on that work. And I also have some questions about the imputation. So now I know that in Europe, in Finland, the late 90s, early 2000s, they also were doing a lot of imputation with the National Forest Inventory. So did you have communications with those groups? I think it was Erkki Tompo, one of the big names there.
Yes, and in fact, I think it was Finland. Yeah, I was pretty sure it was Finland. One of the functions in yaImpute was built to meet one of their needs, and let's see if I remember it. The need was they wanted to do a kind of a wide area imputation model, but when it came to actually picking neighbors, they wanted those neighbors selected from subsets of that original data. And so there's a way to do that now in yaImpute. You can kind of screen the neighbors based on a category that you code. So I did have some communication, and also one of their scientists, I don't remember his name, was in Oregon State. Gosh, I can't remember his name. He found a bug in my code, and I was forever grateful for that. So, but he wouldn't have found it had we not been open with our code. So, yeah. I'm a little rusty on what's going on. Oh, Bianca. Bianca just said something.
Yes, Bianca said that the person that found the bug was Petri Pakalen.
That's right. Yeah, yeah, yeah. I worked with Bianca as well, and we had a little competition between us about which algorithm might be faster in one of the steps. But it was it's hard to remember everybody, but everybody contributes.
And who won the competition?
Bianca can tell you. I think I won that one. It was
Okay.
yeah. Yeah, she had some really cool ideas that were faster on specific problems, but of course the situation is you didn't have a surefire way to know whether or not you had one of the problems that would be faster. So on average, my approach was faster, but I think on specific problems hers was. So, anyways, yeah.
So,
Yeah.
are there more questions? So we have one from Changyun Choi from Korea, and he's asking, as far as I understood, it seems that the Forest Vegetation Simulator use many of regression models like random forest. I think still you use some equations about basic rules. How do you find those equations? You develop the equations by yourselves or find them in some papers?
Oh, okay. Well, most of the time they're developed in-house. They're developed by us. Where if you people's research that are published as papers are often the basis for some of the thinking, but it's usually the other way around. Usually we build the models, and then we build this stuff and build it in the models, and then publish the model in papers. That's how it was done most of the time, I would say. Or if the model was just another example of the same model forms, then those equations are just published in general technical reports. but that's another difference between the emphasis of the work in research in the research group, which was in Moscow working for the research community, versus National Forest Systems. National Forest Systems there was no big reason to publish. That's not what they were paid to do. And in research, we had more of an obligation to publish. So, yeah, there was a question that came up on whether or not FES is used outside the United States, and I forgot to include any information about that. But the answer is yes, to some degree. Canada, for sure. There's a BC variant, Ontario variant. ESA Technologies is involved with that. There was an effort several years ago that I was peripherally involved in to port it to some forests in China. I don't know what happened to that effort in the long term. I know that the supposed user interface was ported to there, and it was really fun to go to Beijing and see someone do a presentation and having all the code I wrote, except everything was in Chinese instead of English. So at any rate, that occurred. There were some efforts in Europe to try to use the model for various purposes, but I haven't heard anything recently. But I haven't been in the loop either, so I don't know.
Yeah. Yeah, that questions about, or that question about the use of FBS outside the US is something that I heard several times, and well, people want to use FBS, I think, because it's a very complete system, and probably it's easier to adapt some parts to all the framework that has been already developed, and then starting something from scratch. So
yeah, and I think
Mhm.
that's really true, and I think that it's if someone wants to work on it, if someone wants to take the code um, and work in that direction, that could be easily done. And the Canadian variants are all the outputs are in metric, so that's an issue. Internally, a lot of those equations are still not, but so units of measure conversions is an issue, but it's certainly possible.
Well, I also want to share something that I used preparing, or in the conversations with you, to prepare the seminar that is related to the question from Chang Jung, and is the archive of documents from the FVS webpage of the Forest Service. I'm going to put that link in the um, in the chat, and maybe one question that is also very related to this documentation is how much effort it took to develop all those documents, because there are many manuals, some of them very long, and I imagine that was a lot of work.
Yeah, and a lot of people
Mhm.
were involved, and there was, yeah, but but it was crucial. I think that's one of the reasons FES is successful, is that it's in fact, there are documents people can go to. You can you can question results, and then you can go find out what is actually behind those results. And if you have something better or something you'd want to use instead, it's not that difficult to go that direction. So the openness is one of the key assets of the model. That's my view. When I was talking to Aaron Smith-Matea this morning, this morning my time, and she said it's still the only public domain software that is approved for carbon accounting. And so $1 million decisions are being made in the carbon markets all the time based on those output. And what's behind them? Well, you can know what's behind them. You might not like it, but you can know. I think that's very important.
It is.
Yeah.
So, Nick, it's well, it's 2 a.m. for me. It's the or 1 hour after we started. I don't know. Probably I don't know if someone has a very quick question. If there are no questions, I just want to thank you for giving this webinar. It's very interesting. Also, thank you for all your work. That is extremely useful for many people. And if there's no more questions, we can end the webinar with an applause.
Well, thanks for having me. And in your notes to people, you can put in my email. If they have something that they want to ask, they can just send me a note. That'd be fine.
We will do that. So
okay.
we have to post a small report about the webinar on the IUFRO webpage. So we will include your email there, and if someone wants to send you more questions, they will have your contact there.
Okay, that sounds great.
Well, thank you again. Thank you very much, and thanks all the attendees. I'm going to stop the recording now, and you are free to leave if you want.
Okay. Well, thanks for having me. Thanks, everyone.
Thank you very much. Thank you.
Bye.